Let's take this example circuit. We have a 12-volt battery. We have two 2-ohm resistors wired in series. If we color code these wires, the top one we've learned to color high pressure red. The bottom one connected to the negative battery terminal is low pressure blue. And if you have a series circuit with two resistors of equal resistance, you're going to get an equal pressure difference across those resistors. Of course, we're going to have the same current going through each of those resistors because there's only one path for the current to flow through. That will be the same current that flows through the battery. Now what I'd like to do is assign electric pressure values to each of these wires. We know that the blue wire is the lowest electric pressure. So I'm going to assign that 0 volts of electric pressure. Across the battery, there is a 12-volt difference. Well, if the blue wire is 0 volts of electric pressure, then the red wire must be 12 volts of electric pressure, which means that the yellow must be 6 volts. The current going through resistor A is going to be, according to Ohm's law, the pressure difference across resistor A, 12 on one side, 6 on the other, so the difference is 6, divided by the resistance, which is 2 ohms, so 3 amps. Similarly, for resistor B, the pressure difference is going to be 6 volts, 6 volts on one side of resistor B, 0 volts on the other, so the difference is 6, divided by 2 ohms, 3 amps, just like we expected. And the current going through the battery will also be 3 amps. Suppose we take those same circuit elements, but now we wire the resistors in parallel. Now, the entire top portion of the circuit will be high pressure red, the entire bottom portion of the circuit will be low pressure blue. We're going to have more current going through those resistors now, and we will have a lot more current going through the battery. If blue is the lowest pressure, and low pressure would be 0 volts, then this red pressure must be 12 volts. 12 volts difference from one end of the battery to the other. The current going through resistor A is going to be the pressure difference, which will be 12 volts, divided by 2 ohms of resistance, 6 amps. Same for resistor B. So if you think of through resistor A, 6 amps, 6 amps, 6 amps, 6 arrow tails. Through resistor B, 6 amps, 6 amps, 6 arrow tails, 6 amps, 6 amps, 6 amps, 6 amps. Right here, we've got 6 amps coming through from resistor A. We got another 6 amps coming through from resistor B. They come together, so the current going through the battery is going to be 12 amps. Let's do a similar setup, but this time we'll have different resistances for these two resistors in parallel. We'll color code the wires again. We're going to have a certain current going through resistor B. Resistor A has the same pressure difference, red to blue, namely 12 volts, but it has a lower resistance. So we'll get more current going through resistor A. And we should get the sum of those two currents going through this battery. If we color code these wires and pressurize them with numbers, low pressure blue will be 0 volts, high pressure red will be 12. The current going through resistor A is the pressure difference, 12 compared to 0, so the difference is 12, divided by 4 ohms, 3 amps going through resistor A, through resistor B, 2 amps. Notice that the arrow tails that I picked didn't exactly match up with the actual currents, but relatively, in terms of more and less, they are correct. The current going through the battery will be 5 amps. Final thoughts on Ohm's law and Castle. Ohm's law expresses the relationship between pressure difference, that is voltage, flow rate, or current, and resistance. In Castle, students learn to color code wires according to pressure and to assign ballpark quantitative values for currents based on pressure differences and resistances. That is, more arrow tails or fewer arrow tails. Here, we took the next step of assigning numbers to voltages and then used Ohm's law to compute current. currents.